So, hey guys, welcome to today's tutorial. We are still discussing KVL, KCL, and Ohm's law. So, here is the question on the board. So, the question needs using KVL, KCL, and Ohm's law, find I1, Ix, Vs, and Vx. So, in the circuit. So now to start with, so we need to recall that KCL states that the current entering the node is equal to the current leaving that node. So in this case, take for instance, we have this current, maybe I1, entering that node. So this current will be equivalent to the sum of the current leaving the same node. So take this as I2 and this as I3. So we have I1 minus I2, because I have put minus because I2 is leaving the node. Then I3 is also leaving the node. So the O of this is equal to 0. So in other words, what we are saying is I1 is entering the node. It must be equal to the current leaving the what? The node. So this is the summary of KCL. This is the summary of KCL. So Ohm's law, it is a relationship between, it's the relationship of voltage, current, and resistance. That is Ohm's law. So this is the Ohm's law. This is the Ohm's law. Then KVL. So KVL, we are now talking about the summation of the voltages across a loop. The voltages across a loop must be equal to 0. So take for instance, if we have a loop, we have this loop. The summation of the voltage in this loop must be equal to 0. So we are talking of Vs, Vx, 15 volts. It must be equal to 0 because we assume this is a complete what? A complete loop. So that's it. So now we are going direct into applying these laws. So let us apply these laws. So to start with, we know that this is a node. This is a node. We are talking of this as a point of interconnection between these branches, among these branches. So we have this branch, and this branch. So in this case, we have this current Ix. We have this current Ix entering this node. So this is a node. We have the current Ix entering this node. Then we also have this current entering the same node. So we have two currents entering this node. So let me put this as node 1. This is node 1. We only have this node, and this is the node again. So we have this current entering node 1. At the same time, we have this current entering node 1. So we have Ix entering node 1. So in this case, we are saying this Ix plus 0.5 Ix. So it must be equal to the current leaving the same what? The same node. So the current leaving this node is I1. So these are like terms. So we can add. So Ix plus 0.5 Ix, we get 1.5 Ix equal to I1. So I will keep this as my equation 1. That is my equation 1. So this is my equation 1. Then next, what else am I given in the question? So it is very possible to come up with a value of IOI. So it is very much possible to come up with a value of what? IOI. So in this case, the value of IOI, I have been given the voltage and I have been given the resistance. So it is very possible to know the current what? IOI, simply by applying the Ohm's law. So Ohm's law is a relationship of voltage, current, and what? Resistance. So in this case, from the data that I've been given, I have the voltage of 15 volts. And I have the resistance of what? 5 ohms. So it is very possible now to come up with what? Current. So in this case, we say current is equal to voltage over resistance. So in this case, I want the value of IOI. So IOI is simply equal to, my IOI is simply equal to the voltage of 15 volts divided by a resistance of what? 5 ohms. So this gives me 3 amps. So I am getting what? 3 amps as the current. So this is the current. So I am getting 3 amps as the what? The current. So but I also need to come up with a value of what? IX. So IOI is 3 amps. So I have the value of IOI, but again, I have the relationship between IX and what? IOI. So in this case, to come up with the value of IX, this side, IX is simply equal to IOI over what? 1.5. So this is equal to, so 3 amps divided by 1.5. So the value of IX is simply 2 amps. So I'm getting what? 2 amps. So now that the value of IX and the value of IOI are known, so what's next? So I have determined IOI and IX. So I need now VS. So I need VS. So what will be the value of VS? So the value of VS. So what we know is that this current IX is the current which is flowing through the what? The battery or the voltage source. So the current flowing through the voltage source is simply what? IX. So now, what are we going to do to come up with VS? So what are we going to do that will enable us to come up with what? With VS. So first of all, we should start with the simplest thing. So the simplest thing is to come up with a value of Vx, because Vx, we know that Vx is equal to, we have the resistance. The resistance is simply what? 10. And we know the current that is flowing through the 10 ohms resistance to be what? 2 amps. So we can multiply according to Ohm's law. We are saying voltage is equal to what? Current times resistance. So Vx is now known to be what? 20 volts. That is Vx. So even Vx now is what? Is known. So what else? So we are now remaining with what? With a value of, we are now remaining with a value of with Vs. So to come up with Vs, so let me lab this part. But I will keep the answers. I've already solved for IOI to be 3 amps, IX to be 2 amps. So these are my answers. Yeah. So now we want to come up with this value. we want to come up with this value. So now to come up with Vs, when we talk of Vs, we are now talking of the total voltage. So we are talking of the voltage, of the total voltage. So now Vs must be equal to, we are talking of the summation, must be equal to the voltage across this junction plus the voltage across the what? The 10 ohms resistor, which is Vx. So in this case, we know that voltage in parallel is equal. So voltage in parallel is equal. So meaning this voltage, the 15 volts, is the voltage which is across this junction. Even across this junction, we have the what? The 15 with the 15 volts. So even across this junction, we have the 15 volts. So now, as the current flows, we know that voltage drives current around the circuit. Voltage drives the current around the circuit. So it is driving the current across this resistor, and at the same time across this whole thing, because we are now moving from series arrangement going to what? To parallel arrangement. So the voltage across the voltage source is simply the voltage across this series arrangement plus the voltage across the what? This parallel arrangement. But in parallel, we have the what? We have equal voltage. So we are saying we have 15 volts plus Vx. So but the value of Vx is known. The value of Vx is known. The value of Vx is what? 20 volts. So the total voltage across this voltage source is simply equal to, what is 15 plus 20? It is equal to 35 volts. So then we have solved the problem. So this is the application of Ohm's law, KCL and KVL. So thank you so much, guys. So join us in the next tutorial.